Hello, everybody. We are going to continue on with volume. So I would like for you to jump to page 258 in your instruction book. We're going to do the guided practice, ideas about volume with unit cubes. So let's take a look. We're actually starting with number 13. Okay. It was a carry-on from this problem up here. So let me make sure we didn't need to, because we skipped that page just for time purposes. So, number 13, Eli is stacking unit cubes in a box. He partially fills the box, pauses, and says, the volume of this box is 18 cubic units. Explain how Eli found that volume of the box. Go ahead and write down what you think about that one. Or at least come up with your mental thought. Maybe explain it out loud to somebody that's sitting near you. So Eli didn't even finish filling the box, but he already knows the volume of the box. How could that be? Well, what do we know about finding volume? We know that we need 3 dimensions, right? We need the length, we need the width, and we need the height. Does Eli have that? Does he know how many cubes long he can fill in the box? Well, by his picture, I see 1, 2, 3 cubes across. Okay? Does he know how wide his box is? How many he can fit in the depth of it? How deep it is? I see this cube here, 1, so that would be this guy, and 2. So he can fit 2 rows front to back. Okay, so there's our width. Does he have how tall it is? 1, 2, 3 cubes tall. So Eli can pause and figure out the unit or the volume of his box here without even finishing filling it, because he knows the dimensions of the box. So explain how Eli found the volume of the box. He found the dimensions of his box. He found that he could fill his box with 3 cubes by 2 cubes by 3 cubes. So, in other words, Eli found 18 cubic units could fill his box because he has a 3 by 2 by 3. Okay? Number 14, Zoe says that a box that is 1 unit wide, 1 unit, 2 units long, and 3 units tall, look at that, has a greater volume than a box that is 2 units wide, 3 units long, and 1 unit tall. Is she correct? Take a look at what we've got going there. You should have found Zoe is incorrect. Although the dimensions are different on the sides, the volume is the same. A 3 by 1 by 2 is going to equal a 1 by 2 by 3, which is going to equal a 2 by 3 by 1. They're all going to come up to be equal no matter how I flip-flop those around. You can change, just like what you're going to learn next week, you can change around the shape, but if you keep the dimensions the same, what it will hold will be the same. Now, will the area be the same? Would the area of this flat be the same as the area of this flat? No. This one right here has an area of 6 units. This one has an area of 2 units. So the area of one side would be different, but this one would go up 3 times. So that would be a 2 plus 2 plus 2. This one would only go up 1 time. So just this one side, that's as high as it goes. So it would still come out to be the same. So when you're finding volume, if your dimensions are the same, even if it's on different sides, your volume will end up being the same. Okay, your box can fill the same amount, it just has a different shape. Okay, so number 15, each cube in figure A and B has a volume of 1 cubic unit. Which figure has less volume, figure A or figure B? So what they're saying is each one of these little cubes right here has a volume of 1 cubic unit. So it wants to know which prism is going to have the most volume. Well, if I look at the dimensions, I see that the dimension of this guy here is a 1 by 1, 2, 3, 4, 5, 5 by 1, 2. So we have a 1 by 5 by 2. 2 times 5 is 10, times 1 is 10, so this one has a volume of 10 cubic units. Now, shape B is a 1, 2, 3 by 1, 2, 3 by 1. And I know that 3 times 3 is 9, and 9 times 1 is 9. So this one has a volume of 9 cubic units. So figure A has a larger volume. But what does that actually mean here? What it means is, by how many? By 1, right? So what that actually means, if we take this information right here, that each cube is 1 cubic unit, figure A holds 1 more cube than figure B. Isn't that funny that that's how that turns out to be? What it actually means is that figure A just has 1 more of these cubes than figure B does. Okay? Moving on to number 16. Niles used 16 blocks, each having a volume of 1 cubic unit, to build a rectangular prism. So he's going to build some type of a rectangular prism. We had to kind of skip that lesson, so please, please, please go back to the lessons about naming 3-dimensional shapes. Rectangular prism is a 3D rectangle. But this could be turned upside down the other way and be kind of taller than it is wider. Draw or build a model to represent the situation. So here's what you have. You have 16 blocks to work with. Your volume is 16. That's your volume. So they went the opposite direction. They want you to decide what you want your volume to be. Or I mean what you want your dimensions to be of your shape. Okay? So you can build your own shape now. And you can decide how big you want that to be. Okay? So think of all the things that you can make that would multiply up to be 16, and it can't be two numbers. Can't just be two numbers because we have 3 dimensions. So I know that 2 times 8 equals 16. So I could do a 2 times 8 times 1. I know that 4 times 4 equals 16. So I could do a 4 by 4 by 1. Or what if we tried something different? What if we did, let's see, could we do, what else could we do? Oh, no, that won't work. Is there anything else we can do? Not even sure. Something that doesn't have a 1? Oh, I know. We could do a 2 by 2, which is 4, times 4, which is 16. So basically you're just playing around with dimensions. So whatever you decide, let's say I decide a 2 by 2 by 4. Maybe I want it to be 4 tall and 2 the width. Oops. Probably should just go this route, huh? Then make it a 3-dimensional shape. And maybe there's my 3D shape. Okay. So you just need to come up with a length, a width, and a height for your shape and then model it. And the first thing I would suggest on a problem like this is to play around with your options and then just pick one and decide. Okay? Look at your model. Describe the number of layers and the number of blocks in each layer. Then describe a different rectangular prism that also has a volume of 16 cubic units. What's really funny about that, boys and girls, is I was just thinking that I might say to you, it's always good to play around with some of your options because you never know if they might ask you to try a different one. And sure enough, here we are with a different one. So we came up with 3, a 2 by 8 by 1, a 4 by 4 by 1, and a 2 by 2 by 4. So in the model that I have, so the one that I have, the model that is shown, has a layer of I feel like I'm doing this wrong. I'm so used to doing it like this. So let's say I made this a 2, a 2, and a 4 tall, okay? So it's 2 across, 2 back, and 4 tall, okay? So the model that is shown here has an area of 4 square units. So each layer has 4 cubes. And I got that, boys and girls, because you take a look at just the length and the width here, and it's a 2 by 2, which we know for area a 2 by 2 is 4. So that would mean let me try to, I want to get rid of this for a minute. Let me redraw that. That means that my shape has 2 cubes that go this way. See? Boop, boop, boop. And then it has 2 cubes that go this way. Do, do, do. And so the area of this guy is 4. So it has 4. But the reason that it has a volume of 16 is because the height is 4. So there would be 4 layers of that. Okay? And then the top. Okay? Now, you could also do, so you could also design a model. Now is when you go up and you pick one of your other ones that has a layer of 16 cubes. So a 2 by 8 by 1. Okay? All right, boys and girls. I am going to end this video on that note. And let me take a look here at your lesson and recall your assignment. Give me 1 second. Here we go. Okay, your assignment today is practice page 278. So that's in your practice book. It's number 4, 5, 6, 7, and 8. Okay, that is your assignment today.